All right, so the easiest way to get to the website that you need to go to is to go to our Canvas page, because I have it linked right there so you don't have to type it in. So Canvas page for today, right here by task 1, it says, how do outliers affect the LSRL? And you can click on this tiny URL right here. Or you can type in what it says on your page. I'm going to go ahead and pull this screen up so that we can see. So what you're going to do after you click on this link, you're going to add data points here by clicking. And notice it's telling me my correlation coefficient. It's telling me my R value as I do this. I want you to play around adding dots. And I want 10 points total. And I want your R value to be about 0.90. If it's like 0.91 or 0.907 or something, that's okay. You want to get it close to 0.90. If you need to remove a point, then you can click on it. So let me pull this back up. Say I want to remove this point right here. I'm going to click on it if I want to take it away. And so then I can continue adding points. I want a positive 0.90 here, and you want 10 points total. 10 points total with an R value of about 0.90. And then after you get the points on there, you can click on this box that says Show Least Squares Regression Line. So I'm going to click on this right here, Show Least Squares Regression Line. And again, I have way more points up here than you should on yours. You should only have 10 on yours. Let's see what happens if I take away some of these. There we go. So I would add like another point like this. So something along this lines. Yours is going to look different than mine. That's perfectly fine. Click the box so that you can see that least squares regression line. And I know there's not an x-axis or a y-axis on here, but the x-axis would be down at the bottom of the screen. The y-axis would be over here on the left. And we're looking at just quadrant 1 here. So what I want you to do now is I want you to predict if the slope, the y-intercept, and the correlation R is going to increase, decrease, or stay about the same as you add these points that are over here indicated with stars. So however yours is, for part A, I want you to add a point over here. So that would give you 11 points total. And then you're going to see, like I want you to predict and then see what happens to the slope, the y-intercept, and the correlation. And then I want you to take that point away. So take that 11th point off so you're back to your original 10. And then I want you to add a point that's over here, approximately where the star is for B. When you're done talking about your slope, your y-intercept, and your correlation, take point B away. And then do the same things with points C and D. I'm going to give us about 5-6 minutes to complete this part. I'm going to come around and move around the room for anybody that's confused or stuck or lost or not quite sure what to do. And then we'll come back together in about 6 minutes. All right. So let's talk through this. And then I want to show you guys some interesting things. So when you added point A, what happened to the slope? It decreased. What happened to your y-intercept? It increased. And the correlation went down. Why? It was farther from the line. What about when you added point B? What happened to your slope? Decreased again. The y-intercept? Increased again. The correlation? Decreased. Interesting. Point C. What happened to your slope? Mine stayed about the same. Mine stayed about the same. And we'll look at this here in just a minute. Go ahead and change it on your page if that's not what you saw, and I'll kind of demonstrate what I was hoping we would see. What happened to your y-intercept? For point C? Yep. Decreased, yep. Sorry, I got confused about which point I was looking at. I had to look back at my page to see where the star was. And the correlation? Decreased. What about with point D, the slope? Stayed about the same. Y-intercept? Increased. And the correlation? Decreased. So on these first two, we were adding things in the horizontal direction. When you add things in the horizontal direction, it tilted your line, which changed your y-intercept because your slope fluctuated. Points C and D, we shifted the line up or down. My slope stayed the same, or should have stayed the same. The y-intercept changed based on the direction that I put the point in. If I put the point up above, my y-intercept went up towards that point. If I put the point below, the y-intercept went down. I'll come right back to this, but I want to hop. So looking here, what we should have seen with point C, as you add that point, it shifted down, but the line itself didn't tilt at all. And adding the point up above, the line, if I do it straight up above, the line shouldn't tilt, it should just raise up. If I don't get it exactly in the middle, you might see a little bit of a tilt because you also have a horizontal component too. So that might be what you saw when you saw it change. I want you to go ahead and click on this line, or this box right here that says show mean X and Y lines. Show mean X and Y lines. What is mean? The average. So this is the average of all the X's and the average of all the Y's. So here's the average on my X-axis, and then they just made a vertical line through that. And then the average of all the Y values, and they made a horizontal line through that. What happens to this? Like, I want you guys to watch those gray lines in the background, that X mean, Y mean. If I add a point over here, if I add a point over here, if I add a point down here, and up here, did my least squares line ever not coincide with the mean X, mean Y? Watch it again. I come over here, mean X, mean Y is on that line. It's crossing on my line. If I take that point away and I add a point over here, my mean X, mean Y is shifting, but it's still intersecting. Like, all three of these lines are intersecting, mean X, mean Y, and my least squares. Mean X, mean Y, and least squares are all intersecting at a single point. The mean X, mean Y, this point right here, draw this on here. This point right here, that ordered pair would be the mean of X and the mean of Y. So if I had all of the data for X, and I added them all up, and in this case divided by 10, and I took all the Y's, and I added those all up, and divided by 10, that point would be on my least squares regression line. I want you guys to get this note. I want you to draw this, not that part. Add this to your notes about where mean X and mean Y would be, just so you have a little graphical representation to look at. And this note I would like for you to add. The LSRL, least squares regression line, always contains the point, X bar, Y bar. Remember that bar over the top just means average or mean. Why do you think these 4 points, A, B, C, D, that we added, why do you think those are considered outliers? They don't increase the correlation. They decrease the correlation. You guys are agreeing, and you're saying what I'm wanting you to say, just using different words. When you decrease the correlation, does the scatter plot look like more of a line or less of a line? Less of a line. So it's not really following this linear pattern. You're absolutely correct. The effect that that has is that my R value is going to go down or closer to 0. So we are not following the overall linear trend. Another way to look at this or to talk about that, they have really large residuals. They're decently far away from our least squares regression line, so they are pulling that least squares regression line towards them. Anytime we have a point on our scatter plot that has a very large residual, that's having a big impact on my least squares regression line. Which of those outliers, A, B, C, D, had the greatest impact on the least squares regression line? Was it the horizontal ones, A and B, or was it the vertical ones, C and D? It was the horizontal ones. We call those high leverage points. High leverage points. You guys have all learned about simple machines in science class, right? Levers and pulleys and all of that. So when we're talking about high leverage points, I literally want you to picture in your mind a lever with a fulcrum on it. That point on our least squares regression line, X bar, Y bar, that acts like the fulcrum. It's the center of mass for our line. When we add these influential points, it is going to shift. This is being picky on me now. It's going to shift this, but it's going to pivot on that. Does that make sense? Like, I'm not able to get it exactly on, so we're also having some changes in where the line is located. But what I want you to picture in your mind is that X bar, Y bar is the pivot point. It's the fulcrum for this line. So it is a high leverage point, outliers. Influential points are points that if I remove them, they substantially change the slope, the y-intercept, and or the correlation. So to be an outlier, it just means it doesn't follow the linear trend of the other points. Influential points are any points that if I take them away, or in our case, we were adding them, when you add them or take them away from the picture, your y-intercept, your slope, your correlation, any or all of those are changed or greatly affected by that point. And then the high leverage is specifically when we see that line tipping because we've got something far in the horizontal direction, either far to the left or far to the right in the horizontal direction. So far, so good? All right. I would like you guys to do some follow-up reading tonight on these concepts. We're still going to do the back side of this. But the reading that I want for you guys tonight, it's short compared to the other reading assignments I've given you. It's 6 pages. 197 to 203 is what I want you to read. And it's going to go more into detail about these, but I wanted you to kind of see what's happening first before you read about it. Because if you read about it first and then you see it, like the reading about it, you're like, what are you talking about? But seeing it and playing around with it. And you guys can get back into this at home, get into Canvas and play around with this. As you're reading through the book, if something's not making sense, get in and play around with this program. All right, so takeaways, and I mentioned this just a second ago. Outliers are out of the pattern, things that have large residuals. High leverage, specifically we're looking at very small or very large X values, horizontal things. Influential points, if I take it away, there's a big change. Outliers on the least squares regression line, horizontal outliers are going to tilt the line, vertical outliers shift it up or down. This right here, we didn't practice this so far. We're getting ready to do this. But this is how you can calculate the least squares regression line if what you know about it is R and then SY and SX. I want to mention what those are. The book goes into more detail. But SY, this is the standard deviation of the Y values. And SX is the standard deviation of the X values. And if you guys pull out that like orangish formula packet, the one that has table A and the Z table on it, go ahead and pull that out for me real quick. Mine's bright yellow, but yours should have the same information on it. Do you need to know those formulas that are in that lower right box? Yes. However, they're on here. You don't need to memorize them, but we do need to learn how to work with them and use them. So if you look here, I'm looking upper right-hand side. It's right underneath this horrible-looking square root thing. It says y bar equals A plus b x bar. And right underneath that, it says b equals r times sy over sx. You guys see that on there? I want you all to know where to find it, because if I ask about it on the test, you're going to need to find it off the formula page. I won't give you the formula on the test, but you'll have access to it because you will get this. All right, I want to practice using that now. Looking at the check your understanding, you've probably heard the saying that practice makes perfect, but does practice also help you complete a task faster? To find out, a random sample of 15 high school students were taught how to solve a Rubik's Cube. They were each randomly assigned to a number of times to practice this new skill. After they completed their assigned number of practices, they were timed solving the Rubik's Cube. Here is a scatter plot of the results along with the least squares regression line. So right here. And we'll talk about number 2 in a minute. I've got some stuff added here because I realized after I had printed everything that I'd messed some stuff up as I was typing it out. So this is my fix to what should be there. But I want to look at this first part. Consider the student who was assigned to practice the Rubik's Cube 14 times. That's this chicklet. How does that point affect the slope, the y-intercept, and the correlation of this line, of this relationship? What's it doing to my slope? Do you think it would increase it or decrease it? Sorry, I can't hear, so that's why I'm not responding at all. My y-intercept is not, or sorry, not my y-intercept, my slope is not going to stay the same. See how think about where your y bar would be and where your x bar would be. The average of these. What's the smallest x value we've got? Well, here would be 2. Looks like there's maybe some zeros and a 1. I think this one over here might be a 0 and that one might be a 1. And it goes all the way up to what? All the way up to 15. We've got, 15 different dots on here. I don't want to add up all those x values. But if you were going to guess about where the average was, we would expect the average to be roughly in the middle. So x bar would be, I don't know, like here-ish, right? Y bar is going to be about here. Remember, the x bar and y bar have to cross on that least squares line. Is this far enough horizontally that it's going to change my slope? Yes, this would be considered a large x value compared to where my mean is, compared to where my average is. So it is going to change the slope. These outliers are always going to pull the line towards themselves. So this point up here is going to pull the line this way. Is this a positive or negative sloped line? Negative sloped line. So this point right here, if it pulls my line up this way, what's it doing to the slope? Increasing it or decreasing it? It's going to increase it. It's making it less negative. It's pulling that line towards it. It's making it less negative. What's it doing to the y-intercept? It's decreasing it. If I were to take that point away, if I were to take this point out, my line would tip more down and the back end would go up higher, right? What's it doing to my overall correlation? It's decreasing it. It's not following that linear pattern. So hold on and I will get all of that up here. Slope is being increased. It's making the slope less negative, decreasing the y-intercept, and it's making my correlation weaker, closer to 0. In this case, my correlation would be a negative correlation because we have a negative slope, so I don't necessarily want to say that it's making it smaller, because that would indicate in my mind that it's going further to the left on the number line. But if we get all the way to -1, that's a really strong correlation. We're getting closer to 0 there, weaker correlation. All right, stuff that I had left out. I don't know how well, I lied. I do know how this happened. My eyes just jumped lines as I was typing things out. I want to find the equation for the least squares regression line for predicting time to solve the Rubik's Cube. X bar is 8 practices, so that's the same as what's on your page. SX is 4.47 practices. Please go ahead and change that on your paper. SX, the standard deviation of X, is 4.47 practices. They give us the R value. And then this part is the part that got totally left off. The mean and standard deviation of time, my Y variable. Y bar is 7.71 minutes. And SY, the standard deviation of the Y's, is 1.20 minutes. I want to give you guys a couple minutes, but I want you to find the equation of the least squares regression line. So you're going to use those formulas that were up in the lower right part of the box for finding A and B. Or you can look at your formula sheet for how to find A and B. Look at the pieces that you need to find B. Find B first. And then find A. I'm going to give us about 5 minutes for you guys to do that, and then we'll compare your work with mine. All right. How do we find B? Yes, R times SY over SX. What was the R here? Negative 0.793 times, what is SY? 1.20 over 4.47, giving us a B value of what? Yep, negative 0.213. Yes. All right. We found B. Real quick, thumbs up, middle down. How do you feel about finding B? Awesome. Finding A. This is where I need to use the fact that y hat equals A plus BX. And we've been given X bar and Y bar, so I can look at it as Y bar equals A plus B times X bar. We just found B. And we were given Y bar and X bar. What's the Y bar that we would want to substitute in there? 7.71 equals, we don't know A, so I have to leave it as A, plus what? Or minus what? Yep. Minus 0.213 or plus a negative 0.213. And then times our X bar, which was 8. You should get an A value of 9.414. Yes?
So I use the formula A equals Y bar minus B.
It should still give you the same thing. So all that they did there was they took and rearranged that formula. They said if Y bar equals A plus BX bar, we're going to subtract BX bar from both sides. So it would cancel out over here, so you'd end up with Y minus BX bar. Does that make sense? Okay.
That was close. I got 9.406.
Okay, it probably was just like a single number that didn't get typed in correctly. Last thing you needed to do here, though, was to actually write out the least squares regression equation. If you have not done that, take a moment to do that. You should write it out in context, not y hat, but whatever the y variable represents. What is our y variable? Time, or you could say minutes. I would take either one. So either time hat or minutes hat equals 9.414 minus 0.213 times what? What is our x variable? Number of practices. Yep. Nice job. There is the opportunity to practice this part on your test review. I told you I'm not going to give you a homework just over the one-day lesson. That doesn't make a whole lot of sense. But there's the opportunity to practice this in the test review several different places. If you guys remember, tomorrow I'm going to be out. I'm going to be at AP Stats training. You guys have an assignment on Canvas. It's like I told you the other day, it's some multiple choice practice. I want you to get in and do the one that's in Canvas first. Then I want you to go over to AP Classroom, and this is written out on the agenda on tomorrow's daily page. So if you forget, you can go to tomorrow's page in Canvas. It's got all of the tasks in the order that you should be looking at those. So after you get done with the multiple choice that is linked in Canvas that'll take you to a Google form, then I want you to go over to AP Classroom. There are 2 sets of multiple choice questions there that I want you guys to work through. I've also assigned some videos. If you don't get those done tomorrow, that's fine, but I want you to work on the multiple choice practice tomorrow. If you do get done, then you can go ahead and watch videos or work on the test review. You are allowed to work together on the multiple choice practice. I'm leaving that in the sub notes that you guys are allowed to work together. I am also fine if what you want to do is put some earbuds in so that you can focus, listen to some music while you're doing the multiple choice practice. That will also be in the notes for the sub. So you can listen to music, you can work with a partner, multiple choice, multiple choice, multiple choice. Once you get done with that, you can move on to the paper review or watching some of the videos in AP Classroom. All right?